Welcome to my video on how to solve a 2-resistor series circuit. So let's go ahead and take a look at the circuit. So here I have 2 resistors in series. And we'll mark this one has R1 and this one has R2. We'll make each value of each resistor 1 kilo ohm, and we'll give a 10 volt source. Now a series circuit can be identified by current having one path and only one path. So let's take a look at this circuit. Current comes out of the source, goes into R2, comes out of R2, goes into R1, leaves R1 and enters back into the source on the positive side. And as you can see, we had no choices. We had to go through R2 and we had to go through R1. There was no choice. So that allows us to identify a series circuit. First values we need to find are the totals. So we need to find V total, our voltage total, our resistance total, our current total, and finally our power total. There's only one source in this circuit, so our voltage is going to be that source voltage, which is 10 volts. Alright, let's find the resistance total of the circuit. The resistance total is equal to the sum of all the resistances in the circuit. And in this case, we only have 2 resistors, R1 and R2. So our total will be the sum of those 2 resistors. R1 is 1K plus R2, which is also 1K. Now remember, K is an engineering notation for 1000. So K equals 1000, or 10 to the third power. So when I say 1K, I'm actually saying 1 times 1000. And in this case it is 1000. Now, by knowing a power of 10, we can use our calculator to quickly and easily find our answers. The exponent key on your calculator represents times 10. So when I hit that and then hit a value afterwards, I'm doing times 10 to that value. So let's go ahead and do our total. Alright, now I'm going to go ahead and enter it into our calculator. So the first thing we want to do is hit 1. And now, because we have K, and every time you see a letter, you're going to hit the exponent key. Now K is 10 to the third power, as we mentioned down here. So we're just going to hit 3. And as you see on the calculator, we have 1 times 10 to the third power. So I'm going to go ahead and hit plus. And now we're going to take care of the other value, which again is 1K. So I enter 1 exponent 3. I'll go ahead and hit equals. And as you see, our answer is 2. And it's times 10 to the third power. So our total was equal to 2K ohms. And I'm going to go ahead and put that in our answer key. Before we do current, let's go ahead and take a look at our Ohm's Law triangle. Our triangle states that we have V over I, current, and R, resistance. And the easiest way to use the triangle is cover up the one we're looking for. In this case, we're looking for I. So if I scratch I out it tells us that the formula is voltage divided by resistance. So here I have current total will be equal to voltage total divided by resistance total. Our voltage is 10 volts and our resistance total is 2k ohms. So let's take a look at our calculator. So we'll put in 10. Now, because we have no engineering notation here, no letter, we do not hit the exponent key. We do not touch the exponent key. So we have 10 divided by, and now we have 2k, and there is an engineering letter, so let's go ahead and put 2 exponent, and k is to the power of 3. So when I hit equals, my answer becomes 5 times 10 to the negative third. So we have 5, and if we look up what negative 3 is, it is milli. So our current is 5 milli, and current is measured in amps. So the current through the circuit is equal to 5 milliamps. And let's go ahead and put it in our answer key. As with Ohm's law, we have Watt's law. Our Watt's law triangle states that P, power, is over current and voltage. So like our Ohm's law triangle, we cover up the one we're looking for. In this case, we're looking for P. And it tells us that power can be found by current times voltage. So P total is equal to current total times voltage total. Our current is 5 milliamps times 10 volts. So let's go ahead to our calculator and put the values in. We put in 5. Now we do have engineering notation, milli, so we want to hit the exponent key, but milli is negative 3, so we have to hit the plus minus key and then 3. And that takes care of our milli. Times 10. And again, we don't have any engineering notation here, so we would just put in 10. And that equals 50. And as you can see, it's times 10 to the negative 3. So my power consumption for the circuit is 50 milli, and power is measured in watts. So let's go ahead and put our 50 milliwatts in our answer key. Now that we've found the totals of the circuit, it's time to find the individual resistor values. So we're going to need to find VR1, or the voltage across R1, IR1, the current through R1, and PR1, power consumed by R1. Well, same thing with R2. We need to find VR2, IR2, and PR2. Now I'm going to go ahead and put on Ohm's Law triangle, which is V over I R and Ohms Law triangle, which is P over I V. Now, for us to solve for these individual values, something from the total must remain the same. We know that resistance changes. We have R1 and R2, but either voltage or current must remain the same for us to calculate the remainder of the values. And in a series circuit, current remains the same. So for our circuit here, our current is 5 milliamps. So what I do is come over to the answer key for the individual resistors and put 5 milliamps. And that is the current through both resistors. So again, in a series circuit, current remains the same. Now, using Ohm's law, we want to find voltage. And if I cover up voltage, we find that we can find the voltage across the resistor as current times resistance. So, VR1 is equal to the current, which is going to be 5 milliamps, times the resistance. So we put 5 milliamps times 1 k ohm. And let's go ahead to the calculator. So we have 5, and of course this is an exponent. -3 is what milli is, times 1k. 1 exponent +3. And we get an answer of 5. But notice our power of 10 here. Our power of 10 is 0. So there is no engineering letter. So we go ahead, it's 5 volts. So the voltage across R1 is 5 volts. Now that we have voltage and current, we could go ahead and use Watt's law to find power. So PR1 would be equal to IR1 times VR1. And that is 5 milliamps times 5 volts. So we have 5, and of course we have engineering notation, so that's exponent. It's milli, so it is -3 times 5 volts. 5 is by itself, so it's just times 5. And when I hit equals, we get 25. So I'll put 25 here. And we have here 10 times -3, and that is milli. So this becomes milli, and it's power, so it is watts. So down here in our answer key, we have 25 milliwatts. Now it's time to go on to resistor 2. So when we look at resistor 2, to find voltage, it is current times resistance. So VR2 is equal to IR2 times R2. IR2 is 5 milliamps times R2, which is 1K ohms. So again, we put in 5 in our calculator. We have a metric notation, our engineering notation, exponent -3 times 1K. 1 exponent 3. And when I hit equals, I get 5 and no powers of 10. So my answer would be 5 volts. PR2 is equal to IR2 times VR2. So we have PR2 equal to IR2 times VR2. Our current is 5 milliamps and our voltage is 5 volts. So we have 5 exponent -3 for our milli times 5. And our answer is 25, and again it's 10 to the -3rd, so it's 25 milliwatts. So let's go ahead and put 25 milliwatts in our answer key. As we look at the individual values of the resistors, we see that they're identical, and that's because both resistors have the identical values. To finish this up, we have one more law to look at, and that is Kirchhoff's voltage law. His law states that the sum of the voltage drops on all the resistors must equal the source voltage. So if we take VR1 plus VR2, we better get our source voltage. So I have 5 volts plus 5 volts, and that gives us 10 volts. So yes, according to Kirchhoff's voltage law, because the sum of our two resistors equals 10 volts, and that is what our source is, we've done our circuit correctly.